Hello, everyone, and welcome to today's webinar, Juno Orion AI and VFX Acceleration with Cloud-Native GPU Scaling. We're thrilled to have you join us as we explore how Juno Orion is revolutionizing GPU utilization for AI and VFX workloads. An exciting demo from Donald shall give you all an inside look at real-world AI and VFX workloads in action, enabling you to see how you may benefit yourself from Juno Orion. It's my pleasure to introduce you to Alex, the founder of Juno Innovation, who has been at the helm of driving this groundbreaking technology. Alex, we're excited to hear from you. Over to you.
Hi, so I'm Alex Hatfield. I'm the CEO and founder of Juno Innovations, and we have a really exciting set of technology we're going to share with you today. It's going to be primarily geared towards Orion and what you can do with managing workstations, slicing GPUs, and we're going to do a quick walkthrough of kind of what a day in the life of using it is like. Donald has been using it for quite a while now, at least a few months, and already has got some really awesome things to say about it. But something really cool I wanted to just go over really quick was sort of the history of why Juno became a thing. I've been in visual effects for about 15, 16 years now, and something really neat about it is we wanted to, a bunch of friends of mine and I started working on it on our free time, and we have started making it to the point where as a product, it's starting to be shared a lot, and it's really, really exciting. You can do GPU slicing, you can do a whole world of really awesome things, including, optimizing GPU usage for not just visual computing, but also for AI, which is really, really cool. Primarily, the great thing that Juno does is it's a gateway into essentially into the world of Kubernetes. There's tons of things that you can do in this. We can go through and you can do GPU driver modifications to get a further performance out of your system. You can also do the slicing like we're doing. You can do all sorts of really cool stuff that other vendors can do. But mainly the cool thing about Juno is it opens up the door for you to be able to have access to all of these incredible tools. So that's where Juno really shines, is being able to open that door for you guys to be able to run some of the most powerful tools that are out there in technology right now. And the primary reason that we can do that is because the most prolific piece of technology that's been released in the past 10 years is probably Kubernetes. So something really great about this is we're just enabling you to be able to have access to all those tools, which is really exciting. So yeah.
Okay, well, let's see. Well, thank you so much, Alex, for that great overview. Now I'm really excited to show you two key figures who will be sharing their expertise today. First, we have Donald, Head of Technology at Nexodus, who will discuss his experience with Juno Orion and how his team have leveraged GPU slicing for AI training and their VFX workload. Donald, thank you for joining us.
Hello.
Hi there.
Yeah, so nice to meet y'all. I'm Donald. I'm a more technically leaning person as I progressed in my career, but started out as an artist in VFX. And I found myself more in pipeline and helping teams do the things that they do roles. And as of 2020, that became remote workstations on AWS. Everyone was like, how do we go home and still do VFX work? And the years that followed became exploration there. Everyone at first was like, this is great. We're paying for VMs and we love it. And then we want better VMs and we want more available VMs, and we want it to get better and better and more available. And the one thing it doesn't get is cheaper. And as the years racked on, we had the directive of how do we actually do VFX in the cloud with the convenience that's there and keep doing it where we can afford to scale down, make it more efficient. And I started hearing about Juno at the beginning of, I think, 2024, and I just started emailing Alex and beating down his email here and there saying, I really want to try, give me images. And he's like, it's It's not that simple. So we started a little collaboration on a side project for a different venture over the summer and into the fall, and just discussing like, how can we prove this out on-prem? Oh, once we do it on-prem, we'll be able to move it to AWS. And immediately we could already start seeing how this was a platform that was like letting us settle into stability more than just one more tool that we had to figure out how to, move into our world. So as we began using it, we immediately started realizing we're stacking multiple users on one workstation, what we would traditionally think of as the price point for a workstation, and the flexibility to make things more efficient than a given cloud provider really gives you just opens up immediately once you're on Kubernetes, at least Kubernetes, the way that it's deployed via Juno, and the sort of GitOps and supporting infrastructure that's given to you there. So as we've gotten in, it's been the most, I would say, fortifying process of feeling like every decision we're making is able to be supported from the whole platform. So the more we use it, the more we're confident we'll be able to keep making it more efficient and still remain creative and flexible and not get worried about the price along the way. I think I'm throwing it to Dan now, who's going to tell you a little bit more. Dan is from Juno Innovations directly.
Or no, you mean Dave. Dave.
Oh, sorry.
Dave.
sorry.
We have another Dan at Juno. Juno mixes the two up, but yeah, Dave.
Sorry about that. To you, Dave.
Yes, so thank you. Thanks, Dan. So I'm going to go ahead and bring up the PowerPoint here and talk a little bit about. So we heard from some folks on the call here. We heard from Alex, who founded Juno. We heard from Donald, who's actually using it. So let's talk a little bit about what is it, and before we kind of jump into a demo and show some of the features and capabilities of the software solution. But as was alluded to, really what Alex has done here is created a solution that's really transforming industries by using containerized solutions, i.e. Kubernetes. So really, Juno Innovations Orion platform, it provides an alternative to GPU virtualization. So Donald talked about virtual desktops and virtual GPUs and building those, and they got bigger and bigger. And oftentimes those virtual desktops for remote workloads and workstations often become efficient and bloated. So Alec came up with an idea is like, hey, we need something that's more cost effective, something that's more flexible, and something that's more scalable. We need something different than what we've done. So that's how basically a Juno Orion was born. And really this concept of, and Alex will go more into it in the demo, but this concept of being able to share physical hardware and share physical resources by doing things like GPU slicing, where they're actually able to take a GPU in a system and actually time slice that and share that amongst containerized workloads on the same platform. And this is all using the underlying Kubernetes-based orchestration. So if you're familiar with Kubernetes, you know the power and capabilities that it has at hand. So this really allows us to take a new approach to remote work and remote workloads by actually using containers instead of virtualization. And that gives us all types of benefits. So Donald alluded to, hey, on-prem in the cloud, well, the way that this is built on Kubernetes platform, it's cloud native. So the same software that I would run on-prem, I get the same look and feel when I run it in the cloud. So it's exactly the same thing. Because of the open source integration, everything's API first. So you can make programming calls into Juno Orion to execute things that you want to do. Because it's run on the Kubernetes platform, we have all the scalabilities, the scheduler. We can take advantage of all those things that are built into Kubernetes from the ground up. And really, the partnerships that Alex has engaged in with ourselves and others, and being able to secure the platform, it's a pretty robust solution that's available. So what are some of the key features and benefits that are available? So I made mention of this earlier, being able to time slice a GPU. Maybe you've never heard of that before, maybe you have, but it's the concept of taking a physical GPU and sharing the time or the clock cycles on that GPU with other workers or other workloads on the same physical piece of hardware. So this really lowers your operating cost. Being able to rapidly deploy with Kubernetes. So once your Kubernetes cluster is up and running, it's very, very easy to scale up or scale down to allow for additional workloads that you need to run. Everything's based upon the Kubernetes platform and the containerization of workloads. So very, very easy to deploy and scale things up and down. From a platform capability, being able to support Linux workstations today, workloads, and also with Windows forthcoming down the road. So that's on the roadmap as well. And being able to be hardware agnostic. So really, because if you know anything about Kubernetes, it doesn't really care so much what server vendor it runs on or where it's running, whether it's a bare metal server, whether it's an EC2 instance, whether it's a virtual server running on a hypervisor, it really doesn't care. So it gives you the capability to be hardware agnostic. I'm not tied to a specific vendor or a specific ecosystem, and it really, reduces your dependency on, all these different proprietary vendor lock-in type scenarios. By having minimal image sizes, if you look at the container, a container consumes way less space than a virtual machine does. So reducing the attack surface, integrating things like multi-factor authentication is really going to enhance our security with the system. And by being able to provide a tiered pricing mechanism and subscriptions, making this platform very easy for customers to consume based upon the amount of users, the amount of workstations they want to run in their environment. A lot of the use case we're going to talk about today is specific to VFX, but Orion really goes outside of that, and there's all kinds of different industries. We talk about M&E, which is what we're talking about today for the virtual workstations, the rendering, the animation, all the video editing. We can work with engineering folks, things like CAD, all the engineering drawings, things around the healthcare organization, being able to analyze large medical images, diagnostics, radiology, those type of things. We can also extend into education and research. So looking for folks that want to do a lot of things around high performance computing, analyzation, computation, we can do that as well. Extending into the finance. GPUs are expensive. They're really expensive, and we need to have a cost-effective, high utilization solution, not only for finance, but all these other verticals. Things like aerospace, want to do design simulations. We were talking with a company the other day that launches satellites, and they literally work with rocket scientists. Those type of folks can utilize this type of solution. Anything from medical image analysis, like I mentioned earlier, scans, any of those type of medical procedures, and ranging into things like investment, high frequency trading, where you need high performance solution that's very, very fast and very, very efficient. So these are really the kind of the basics of what Orion is, what are the benefits, and what are some of the industries that we're able to attack here. So with that, I will go ahead and pass it back to Alex, and now we get to the fun part where we can actually see this thing in action.
All right, are we ready? We're gonna do this. So yeah, what I'm gonna do is we can do a lot of talking about it and stuff like that, and we can put up slides, which is great. But I think most of us want to just say hey, are we actually gonna I want to see it do something. We want to make the computers beep boop. That's what we want to do. So I'm going to go ahead and share my tab. Here we go. All right. So I'm assuming everybody can see this, right? It's good. Great. Okay. So this is it. This is what Orion looks like. So the idea here is that, like I said, historically, Juno, I've been working visual effects for a very long time, both as a compositor and I was also a technical director, a cloud architect, all sorts of stuff like that. And the biggest thing I did not want to happen is where you get dropped into essentially a UI with 1,000 different buttons. You shouldn't need a PhD and be a fighter pilot to be able to use this system. That's kind of the goal here. But at the same time, we wanted to still have the capability to be able to manage this and use it as a power user. So system administrators and all that kind of stuff as well. But as an artist, I want to make sure that they could go in and use the system. Now, the funny thing is, like I mentioned earlier, Juno was born essentially for visual effects at first, but the great thing about this was once you make something that's applicable to visual effects, it just accidentally became fantastic at all of these other things, which is kind of where we are now. So what I'm going to do is we're primarily going to talk about Orion's Kuiper system. So Juno is very much spacey themed, so everything's like Kuiper, Orion, Juno, all that kind of stuff. But what we're going to talk about today is just the workstation slicing, which is great. Now, something that's really cool I'm going to show you is we're going to talk about when Juno launches a workstation, you can slice a whole bunch of different things. Now, the thing that we're known for is GPU slicing. That's the really special thing that we do. But in reality, what Juno actually does is it just slices resources, not just the GPU. So that means that if you have workloads that are CPU only, or you need a certain amount of RAM, you do not need a GPU to function in this system. So for example, we have some users that go out and they have nodes that are potentially in just Nuke, and Nuke that doesn't necessarily need a GPU to function. Like you can just use a CPU to do that. So you can pick something on AWS where you can say, I only need a CPU only EC2. I don't need the GPU to function and to use the system. You can do density on the rack. So that means if you're on-prem and you have CPU only nodes or whatever, and you're like, I've got all these blades and I just want to utilize these, you can slice just those in a pool and have that work. But then the GPUs is where it gets incredibly valuable, right? You have a very expensive GPU. I can slice it 2, 3, 4, 5 times if you want to. And you can get all the benefits of that GPU, which is really cool. So Juno as a platform allows you to do this kind of utilization, not just on GPUs. So this is really where it becomes great for something like pen testing, or if you're doing something for like some sort of simulation, you can use GPU pools for this. Nuke nodes might need a whole other set. So really cool things is we have some users that have a whole bunch of towers, old towers that are on the ground from years ago. And they're like, well, we're going to e-waste all this. They can just install Juno, join a Kubernetes cluster, and then we can just slice those existing resources. There's no hardware requirement to use Juno, which is really cool. You can also slice, you can have a mixed cluster. You can have bare metal, VM, you can have mixtures of all of these different types of nodes that you want, which is really cool. But let's go ahead and get started with this. So this is the primary landing page. There's a lot of different products, but we're going to focus primarily on Kuiper, which is going to be the workstation section. When an artist or a user jumps in, typically what we do is we try to just make sure the landing page looks like this. So you can see my workstations are here. In this case, I have a review session. A review session, we'll go over that here in a little bit. But something that's really cool about this is this workstation itself is actually being run by Donald. So this is a really cool interactive session where you're going to be able to see actually what it looks like to use a system, not just like a catered like, oh, perfect little setup. We're actually going to mess with the system a little bit. So on the left here, we have this slide down where I can get to any other system. There's Luna, which is for project management. There's also Terra. We're not going to go too much over these other two, but we're going to focus on the workstations for now. Juno has quite a bit that it can do, but we're going to focus on Kuiper. So I'm going to click on Kuiper. And right now what we have is we have 2 workstations that are currently running. And one of them says join, and it has a little blue swirly thing. And you'll see here it says D Strubler. So this is Donald that's running. And then I actually have my COO, Dan Walters, sitting here as well. And he's doing some development. He's building a pipeline right now because Juno itself has another division called ADA that goes out and does visual effects work as well. So he's actually a technical director building a render pipeline for us. So you'll be able to see us submit a render, hopefully, assuming he didn't break it. He probably broke it. He always breaks it. But so what I'm going to do is I'm going to show you what it looks like as a user that you come in. And if you notice, I don't have a workstation. I don't have one. So what I'm going to do is I'm going to go up here and click request. And I'm going to say I'm going to request an artist GPU. So it's got a GPU instance that's ready to go. I'm going to click launch. And you'll see it says deploying. And then within a second, it'll say verifying. Once it loads up and ready to go, there it goes, verifying. And then now I can connect to the system. So the initial response will probably be like, how did he do that so fast? Like, it's not a VM. These are actually containers. And something that's really great is that if you look down here, all 3 of these nodes, or these workstations, they're slicing the same server. So I have my configuration set up where if I get a GPU node, I'm slicing this now, that single server 3 times. I can go do another one if I need to. Let's pretend and say, okay, this one here is requesting a GPU. Let me also run a CPU workload only. This one here is a production instance. It's requesting 1 CPU and 1 gig of RAM, and it's not needing a GPU. So I'm just going to say, launch that one. It's going to instantly start deploying, and now I can jump between those 2 servers. So we have a mixture of CPU-only workloads, also running on GPUs. And what Juno's doing is it's trying to condense based on the behavior that we've put into the system. It's trying to condense as much as we can. So technically what you're looking at right now is a single EC2 node that's running the support servers, and another CPU, another EC2 that's running a GPU that's being sliced 4 times. So we have all of us going in, which is really cool. So in this case, imagine that I have a GPU simulations going on right here. I also have Donald who's doing something. We'll see what he's doing on his system in a second. And I also have a developer building a pipeline. And then let's say I have a production coordinator checking a render, right? So we have all of this happening on the same EC2. So we're saving a ton of cache that we can do this on. We'll talk about noisy neighbors here in a minute. But what I'm going to do is I'm going to connect to my GPU node. And this is what desktop looks like. I can connect right to the system. This is directly on my browser. Now, the really neat thing about this is, like I said, this is on a Google Chrome tab. So this is actually running in the browser. Now, this is an early build of the interface. This menu over here on the left is being replaced, but you can do multi-monitor support, which are all just separate tabs in the system. I would create another one, but I'm only sharing just this screen, so you wouldn't be able to see it anyway, but I could create as many monitors as I want. I also stream audio directly through the tab, so you can do any sort of audio syncing that you need, or you can watch videos if you need to. And then something as well is that you can increase it to do extreme quality, or even you can do uncompressed. So if you're running on-prem or you're doing something even on AWS and the network can handle it, you can go through and stream 1-to-1 pixel color accuracy if you need to, which is really cool. Donald has already seen that on his side, which is really neat. But what I want to do is I want to show you really quick what it looks like when the GPU is being sliced. So on this node, I'm running just a really simple Tesla T4. As those of you who know, this is pretty much just a 2080 Ti. Like, it's a really underpowered machine, which is totally fine, but we're still slicing it 4 times. And I'm going to go through and I'm going to check NVTop. Now, in this case, I have nothing open, but you can see that the GPU is being used at 90%, but I'm able to use the system. Like, the system's perfectly responsive. I can do anything I need. And as I move this back and forth, you'll see that the FPS at the top right will start going up. So right now it'll say 19, it'll go up to 44, and it'll just keep going up and down because we're scaling the performance as we see fit. So yeah, if you were in the system, you'd be able to see it's actually really, really smooth, which is great. Now, what I'm going to do is I'm going to launch EmberGen on my end. And you'll see that now the GPU has been subscribed to, and we have 2 compute processes that are coming up and 2 graphics processes. So he's using a certain amount of VRAM. I'm using a certain amount of VRAM, and you can see the GPU utilization is being condensed essentially. So we're loading up the GPU with a lot more simulation. Now, while this is loading, because EmberGen takes forever, why don't we go ahead and jump over to Donald? So there's 2 ways you can do this. We're going to start with this one. So in this view, you can see all the workstations. These 2 are mine, but down here we have everybody else's. So this one is my machine right here, which says it's mine. And then down here, Donald has added me to something called a review session. So a review session is a way for me to be able to say, okay, cool. I want to do, essentially, he can share his session with me so I can log in and watch him work if he wants me to help him out with something. Or even if I'm an administrator and he grants me access to his machine, I can control his machine to help out with things. So if you're, for example, a developer or a supervisor and you're doing dailies or something like that, the whole idea is that a supervisor could say, hey, you need some help with something, just share your machine with me and then we'll do it together. So it's a way of collaborating on the machine in a whole other way, which is really cool. So I'm going to go ahead and join his review session. And in here, he's simulating something on EmberGen, right? So he's messing with the light. And like I said, these are very underpowered Tesla T4s. So if you think about it, EmberGen is opening over there. He's messing with the lighting and he's like, hey, you know, I need to mess with some system, right? I need some help with something. So let's pretend, Donald, right? You need me to help you out with something, right? You want to like turn something
off. It's looking pretty bad, yeah.
Yeah, it's looking pretty bad. Okay, so let's go ahead and I'm going to open up and control his machine. And now I have control of the machine and I can mess with it, right? Let's go ahead and turn this off. And wow, it's better when you just turn it off, right? And we turn it upside down. I think this is probably the best way to do this. And all right, approved. That looks good. And so I'm going to jump back to my workstation and say, okay, Donald, that's good to go. Looks great, right? So that's something cool, is we can do this kind of collaboration and move really fast in the system. Now, obviously, this is very much geared towards visual effects in this use case, but you can imagine if you were doing something even in simulation for medical or aerospace or something like that, it allows for this kind of next level of collaboration. Now, the next thing I wanted to show you is what it looks like when a developer does this. So I'm going to message my COO, the message Jan, create a review, please. And so he's going to go through and make the review session, assuming he does it. I have to make sure he's looking at his chat. I told him to, but we'll see if he actually does it. Yep, okay, he just looked at it, which is great. And he's going to create the review session here in a second. And we should see it pop up right here once he does it. There we go. And so now I can join his session. So I'm going to go ahead and take a look at what he's working on. And it looks like he's messing with something to do with the pipeline. And he doesn't know Python at all, and he's a complete noob. So we're going to see what he's doing. It looks like he's building something with UV and making our pipeline. That's okay. Great. Looks like he's installing something. Now, what I really want him to do is he wants to say, okay, well, I need you to help me out with something. So he's showing me his Qt widget. He's building some cool little thing. Juno also offers its own toolkit, kind of like ShockGrid, but like it's our own thing. It's in early development, so it's not an actual product yet, but that's what he's building. So I'm going to say, okay, yeah, that looks great. I'm going to message him and say, can you submit something to the farm from Nuke? And then we're going to see what that looks like. So I just messaged him. We'll see if he does it. He's opening up a bunch of stuff. Let's see. He went over to the other screen. Yep, here goes Nuke. He says, yep, I got you. I'm going to go ahead and open up and do a render. Yep, here we go. And we're not actually advertising like this part of the pipeline, but this is actually showing you what the render farm looks like. So he's going to go through and submit this to deadline. He sets it to the global render range. He just submitted it. And so what's really cool about this is this whole process here is because we're API first. If you look on this screen over here, you'll see in a moment that a bunch of render nodes will actually join the pool. Now, something great about this is because we're API first, this allows us to essentially mount and monitor different render operators. So such as deadline, cube, or tractor and that kind of stuff. And here comes a bunch of render nodes. So they've just joined it. And the neat thing about this is that those render nodes, some of them will be able to slice the existing server that we're already slicing. So if a render node can fit on this server that we've sliced 4 times, we can go through and slice that again and get the render out. Now, something interesting about this is this where it leads to the next kind of issue is how do we handle where, because they're sharing resources. So this is something that we always get a question about. There's 2 different ways to handle this. So you have CPU slicing, which is perfectly acceptable. We enforce limits. So if you have an 8-core machine and you need to slice it, let's say with 4 cores, you can then limit it to say it can only get 4 cores and that's it, right? And then that means that you don't have to worry about it over subscribing the CPU or anything like that. You won't crash the server. Same thing with RAM, same thing, we can cap it there. Now, VRAM is a very different use case, right? So with VRAM, the issue becomes where basically whatever GPU brand you're using, whether it's AMD or GPU, and we haven't tested Intel yet, but we do plan on testing Intel, but you can slice AMD, for example. VRAM itself is not able to be isolated unless you use the underlying operator's configuration, which would be either MIG or time slicing. So multi-instance GPUs, or you're talking about something like just time slicing, which is what we actually use. So what that means is you're using the exact same pool of VRAM. So I'm pretty sure, just a funny story is that we were doing this one day and we were playing Diablo, which was really funny. So we were going through, and I think Diablo is actually on this machine. And we were doing the open source version of Diablo. I forgot I launched this. Let me close this up. I think this is Diablo. No, we don't have it on here. On the other cluster, we have it. But we were all playing Diablo, and it was Diablo 1, the open source version. And we wanted to set the unlimited number of slices that we could get. Well, the highest number that we could get, which is I think you can get up to 16 or 24 or something like that. And we took a Tesla T4 and we sliced it 14 times. And then at one point in time, it just disappeared. Like the server was here, and then it just was gone. Like it just vanished out into oblivion. And so the running joke is that there's a crater somewhere in AWS's racks, and that's where this poor machine was demolished by 14 instances of open source Diablo 1. But we were also doing some simulations and stuff, which was pretty funny. But the thing that Juno is really proud of is our stance on this kind of stuff. So we do not stop you from doing anything that you want to your hardware. If you have a GPU that can handle that much slicing, we're not going to stop you or try to protect you from doing that kind of stuff. If you want to oversubscribe your GPU, you can do that. We're not going to, you bought the hardware, you can do whatever you want to it. If you want to protect yourself with isolated VRAM, you can use MIG, which is a different way of handling this, which actually allows you to isolate VRAM. Or if you want to do time slicing, which means that you don't need a grid license, you can go through and just subscribe to the same GPU and keep slicing it. But the concern there is that you can oversubscribe it. With MIG, you do need a grid license. With time slicing, you don't. So it is totally on how you decide to slice your hardware. Now, we can make recommendations. We can say like, hey, for example, this Tesla T4, we can slice this anywhere from 2 to 3 times, typically on like nuke workloads or maybe doing Blender and some simulations just like this. But for the most part, we'll pretty much not go beyond that. Now, if we have like a C6, or not C6, sorry, a G6 instance on AWS, that's like a 4090 or a 4080 or whatever it is, we can slice that like 4 or 5 times and not have a problem. So yeah, that's kind of the gist of what we do, right? Is so we allow you to have access to this world inside of Kubernetes. We allow you to be able to attach essentially desktops and communicate. And the great thing with this is that with this setup, we've been using it in production ourselves for our studio for about 4 years, 4.5 years. And we've done a number of different high pressure commercials, a lot of Toyota, GM type stuff. And something really cool was that we were able to, on AWS, go through, and in a day, we got the contract awarded. And within about 2 hours after that, we were completely deployed to multiple regions across the world where we had artists logging in. They've never used the system before. And as you can imagine, it's pretty easy to go up here and be like, all right, this is your landing page. When you launch a workstation, you just go over here and click request, pick the one that we tell you to use, and then they can start working. And then they're presented with a desktop that's kind of like Windows. They don't need to open a terminal, and they can just click run nuke and whatever. So it means that our studio is incredibly flexible, very, very powerful, and we can scale pretty much anywhere in the world, which is great. And another really kind of happy side effect to this was that originally Juno didn't have any backing from any other, like, Amazons or anything like that. So everything that you see today has been built essentially on some mini PCs that were originally bought from McDonald's. Like, no lie, like the little screens that you have at the point of sale machines. If you look at it behind them when they're putting in your order, strapped to the back of it are these little miniature PCs or HPs. You can get different ones. And you can buy them on Amazon for like $80. And so I bought 4 of those, and that's actually what Juno was originally developed on over the last 2-3 years, last 4 years, with these McDonald's machines. And so the cool thing is that everything you see here that you just saw works exactly the same way on-prem that it does on AWS. Oh, you there? Did I get disconnected?
I wasn't able to hear sound. Apologies, but now I can hear it again. Thank you. Sorry about that. I don't know what happened. Did we possibly have any more demos that we could share from Donald's side?
Nope. Totally up to Donald if he wants to show anything.
Okay, I may have just lost my signal because I'm just now hearing you. Can you say that again? Because I just heard Donald if I want to show anything. What'd you say?
Apologies. No, I think that it crashed for a lot of us. I was just wondering if there was possibly any type of workload that you wanted to show from your end.
Workflows. I have nothing to show other than my awesome Embergen that I'm in right now in the SQM environment. But I did want to describe the cool thing at the venture that we did the initial deployments for, which was that we were sort of progressing into Kubernetes at a time that Alex had offered like the initial deployment for Juno. And with our more immature view at Kubernetes at that point, it was extremely helpful because we were able to start piggybacking our understanding of like good practices and capabilities within the system already without really compromising Orion as a platform or anything that we were trying to do. It's very complementary, and every step of the way, there's never been a cul-de-sac of decision where we're like, crap, we found ourselves, unable to navigate out of this. There's always some sort of component that can be swapped out at the Kubernetes level to make your life easier. The moment we told Alex we need to take this somewhat public deployment and make it private, it was a very simple transition to do based on how this is intended to be structured. So that type of workflow is more or less required, I think, in 2025. So we feel really confident using it.
Hey, Alex, can you talk a little bit about, I know this has come up before in some other conversations about customers who are using other remote clients like Teradici or HP Anywhere, and how working through the browser would compare to that?
Yeah, so as of right now, we currently support two. We support two of them. We support Chasm VNC, which is what you're seeing us use right now, which so far Donald's been using in production with his team, and they've actually, I mean, he could probably speak to that here in a second, but Chasm's been fantastic for us at range. So if you look at compared to something like HP Anywhere, at range, Chasm will perform better in our opinion, especially in the use cases that we've seen with Donald and his team. So like the interesting thing, the reason why we picked Chasm was because of the vast ranges that it works at that, that distance. And the other thing too is you don't need to download a client. As long as you have a browser, you're good to go. And then the color accuracy was pretty incredible. When you go through, you can do, we have a colorist that we work with, and he said, like, calibrating and all the weird color stuff that he does. Basically I said, is this good enough? And then he came back like 3 days later and he was like, oh yeah, this is fine. So I was like, okay, we must be fine. But yeah, so Chasm has been fantastic and we use that at our studio. Now the neat thing is, and I didn't really go over it today, was we have a plugin system called Terra. And Terra allows you to essentially, it's kind of like an app store almost, but what it does is it allows you to take these incredibly out of reach technologies such as the GPU operator from NVIDIA. It allows you to take things like Rust Desk and essentially launch and deploy them into a Kubernetes environment that then Juno can consume. So a lot of the really complicated setup that takes, like for example, Kubernetes setups, that's all completely automated with Terra. So if you've used something like Rancher and you've used their like chart museum or those kinds of things, it's sort of similar to that. But the nice thing with this is it's very much tailored to where we'll pre-configure it to work with our setup. So if you already have something like HP Anywhere, or you have, any of these other kind of clients, it is something where we are reaching out to these other desktop teams to be able to say, yeah, you can just click a button, ideally in Terra, and then you can enable it, inject your license server, whatever you need to do. And then we'll launch machines that are already going to have that running on it. But as of right now, that's not something that we actively support. The only ones that we do support right now are Rust Desk and Chasm, but it is coming in the future very soon. Very, very soon, actually.
Yeah, and I think that's actually a benefit that I don't need a client, right, to use Orion. So that's a cost savings component of that too.
Yeah, that's kind of a cool thing about Juno though, is that like with the licensing that's involved in it, like you don't need to get an HP Anywhere license anymore. You could just use Chasm or Rust Desk, and they perform incredibly well. You also, if you're using time slicing, you don't need to use you don't need an NVIDIA Grid license anymore. You can just slice us with that. So that saves you some cash. And then also we're giving you density on the hardware. So you don't need if you're doing on-prem deployments, you don't need nearly as much hardware because you can add more load to the individual hardware that you've gotten. We have some clients right now that were originally planning on buying, a certain amount of, and the other thing that's really cool is, right, if you look at these huge hypervisors, they go through and they require that you go through and say like, I need to upgrade my hardware for this hypervisor to function. For us, we run on everything. Like I said, we run on McDonald's PCs. So the cool thing here is that you don't need to have like forced obsolescence because we run on almost everything. And so that means that even hardware, like we had, like I said, the client that has all the boxes on the ground, they were going to throw all that out. Now they don't need to, they can add it, which is really cool. So you get this thing where now we have clients that originally they were going to spend, X amount of dollars. Now they only need to spend 70% of that instead, which is really cool. So you're not needing to pay for the desktop license. You don't need to pay for grid. And then on top of that, you don't need to worry about, like, you can fit more on the hardware. And actually the cool thing is the client is buying 70% less hardware, but they're taking that 30% and just getting more expensive hardware that runs even better, so they can fit even more density. So you can get higher quality hardware if you wanted to, and mix it with the old stuff that you have as well.
Yeah, one of the other things we talked about too is that, running this in an AWS, for example, and how great it works as far as reducing latency. It expands your reach for like talent pools and things like that. Can you talk a little bit about that?
Yeah, it's interesting. One of our developers, his name is Alex Cantonar. We have 4 Alexes at Juno, and we only have 6 employees. It's incredible. We're incredibly saturated with Alex's. But essentially, he's out of Croatia, and he is somebody who's been a really good friend of ours for quite a few years now. He works at some studios that use No Machine and also use Teradici right there in Germany, so not that far away. And he connects to our system over AWS's backbone in Virginia, and he gets better performance using Chasm at range than he does getting connections to Teradici down, not that far away in Germany. So he can go clear across the ocean and still get that. Obviously, latency, you can't beat the speed of light. So at range, obviously input latency is just something we can't beat unless we can figure out quantum entanglement. I don't know if we'll ever be able to do that, but we'll see. I have faith, but maybe one day. But the cool thing is that that's where a lot of the stuff that we're doing, the reason why we pick these protocols is because of that range. Like I said, for example, we did have a project where we wanted to access some talent out in India, and we also had some talent out in Eastern Europe that we wanted to access to do one of these commercials. We got the project awarded at 10 o'clock Eastern, and by 11:30, so an hour and a half later, we had 2 Orion clusters up and running in AWS in both Mumbai and in EU, and both of them were up and running by 11:30. The project was done and dusted by, I think, the next day. And it was submitted for review and approved the day after that. So the whole cluster was up and running. And at that point, it was pretty incredible. And the overall save and the cost to spin this up was negligible. It was tiny. It was almost pure profit for us, which was really cool.
Yeah, there were some comments in the chat about someone had mentioned about, exciting to see the software. There are a lot of use cases. They'd mentioned things like medical, and one interesting one, they talk about engineering or offsite oil and gas. It makes me think about oil platforms and being able, because we've talked about this with other customers about having dark sites, and it's completely capable for that, correct?
Yeah. So something that's interesting is, and this was actually brought up to us about 2 months ago, was because it's all browser based, there's clients, and you can do this with Rustdesk too. So there's clients that you can get where they were thinking that a doctor could go through with an iPad, and then that iPad could then just connect to Juno, and then you get a remote desktop into a fully functional machine that would then allow you to be able to sit there with the doctor and talk to them, and they could actually like load up and actually do work together, or they could even walk around as like a research assistant and have access to this really powerful machine off-site that could get all of the simulation data on the fly. So there's stuff like that that's really, really cool. And then, like you said, like at range, if you are talking about somebody who is out on like an oil rig or something like that, that can also work. Obviously, it depends at how far and how good your connection is, because you're probably going to bounce off a satellite. But that's something where, to be honest, we'd love to see that use case. Like we would absolutely, like that would be so cool. That'd be so cool to do that. A really cool feeling at Juno was, like I said, originally it was built to solve industry problems for our industry in visual effects. And then once we started messing with this, it was like, oh, this is so cool. You could do 1,000 different things with this, millions of things with this. And then it became where we can go so far beyond what visual effects is doing. Like, it's so cool to make really pretty pictures, but wouldn't it be really cool to be one of the companies that's trying to, like, fix medicine or something like that? That would be so cool. And it's the same technology, which is really neat.
Well, and another thing that was in the comments about talking about AI inferencing, right? Taking it to that degree, and I think about hey, when we're able to kick off render nodes, what if we could kick off inference nodes as an example for our process?
Yeah, so that's something really cool. So we do allow for the Juno's API is very simple, but in a really great way. Like, obviously I built it, so I'm a little biased, but I mean, the great thing about that is it's not like, if you look at, we absolutely adore AWS. They're really good friends of ours, but have you ever looked at like their API? It's like their docs, like when you open up their API page on Google, like it takes like 30 seconds for it to load because there's so many endpoints. It's insane. So what we did was we really didn't want to get into that world. One, we don't have that many services, but two, we wanted to make it so that like you launch a server, you can manage the life cycle, and then take it from there. Like, we don't want to sit there and be like, now here's 1,000 different ways to do it in these different, we just want to give you the building blocks, and it's up to you to assemble it. We're essentially Lego, right? So we'll give you the blocks, build whatever you want. That's kind of what we're doing. And you can see that evidence in the way that we treat the hardware. You can abuse your hardware, or you can be super conservative with it. Totally up to you. But like I said, we're essentially just giving you the building blocks. So people that are doing AI inference and stuff like that, there's nothing stopping you from hitting our API, and you can launch other containers that are not workstations. You can do AI inferencing, and we can manage the life cycle of that whole stack for you. And then it just becomes another workload that Juno runs. So that's where it becomes really, really awesome.
Yeah, it makes me think about, I'm just thinking outside. I wonder if we could do like an AWS where you could kick off maybe some model training on spot instances, but figure out how somehow to checkpoint it in case the spot instance goes away. But
well, that's the interesting thing, is that there's companies out there that do have solutions for stuff like that. So and they're all Kubernetes based, which is really great. So there's companies out there that are working on making it so that containers themselves can move seamlessly between spot instances without interruption or failure, right? That's a thing that's out there. But Visual Effects has never had access to that technology. But it's funny because what's the biggest cost? Like you go to spot instances to do massive rendering in Visual Effects because it's cheaper. But let's say that render took 2 days, and then literally right before it finishes, that spot instance goes away, you lose everything. So now you just lost the entire benefit of using a spot instance. So, but it's funny because if you look at the Kubernetes environment, people have been doing this motioning of containers for years now, because that's how like AI gets trained, because you don't want to lose all that state. But Visual Effects never had access to it because they aren't on Kubernetes. So the cool thing is, because we're on that platform, we all of a sudden have this Visual Effects studio and this platform that has access to all of this incredible technology that's being built across other industries, which is insanely valuable. Like our studio can do things that other studios have only dreamt of just because we're built in this way, which is incredibly cool, incredibly cool.
Yeah, there's a question in the chat, and I know the answer, but I'll let you answer. They talk about being able to provide access to shared file storage.
Yep. Yeah, so this is exactly like the previous point, right? So the interesting thing is, like I said, Kubernetes is probably the most prolific piece of technology that's come out in the past 10 years. Now, the great benefit to this is that all Kubernetes really is just an abstraction of like, I don't really care what your hardware is. It's just CPU, RAM, or a GPU. That's all it is. And the same holds true for storage. And so what we do is Juno is not in the business of storage. We're not that smart. We're not able to do backups. I don't even trust myself to do an rsync backup of one of my McDonald's PCs. Like I can't do it, right? It's not happening. I mean, I can, but like, I don't trust myself. It's not a thing. I don't think anybody whatever. But but look at Cumulo. Look at like Weka. I mean, I'm looking at FSX, AWS, all that kind of stuff. So the great thing about this is that those guys, what's the number one thing that they've done lately is they've started making Kubernetes drivers. So the great thing about this is exactly the point I just talked about. If and Donald's already realizing this at his other venture, is that they have like AWS S3 drivers. They have S3 drivers that are generic. They have FSX. They have Weka. They have Cumulo. They have even what's the other one? Hammerspace. All these different drivers. Now we do not deploy those things. We do not manage those things. But what we do is we sit on top of Kubernetes, which then it is the thing that connects to these things that you deploy, and then they get presented to the containers. So for example, at Juno, we run NFS and EFS, we use CSI, we use all that kind of stuff, and we let those guys handle all of those conversions and mounting and mappings, and then we just allow that to get presented to the containers, and that's how we do our work. And that's where it gets to be really, really awesome, is Juno's able to do these things.
Yeah, very cool stuff.
Yeah.
I think that's all the questions we have in the chat, unless anyone else has anything else they'd like to ask before we start to wrap up here.
Yeah, ask. I'm here. Yes, hold on. Okay. Yeah. I think Donald could probably say something about that EFS driver.
Yeah, it's been our lifesaver the last few days. We were trying to see how much we could get from user experience directly with using Mount Point for S3. And with some of the file writing and needing it to be like POSIX file writing, we decided to leave that in the R&D world for now and just immediately shift over to EFS. And to Alex's point, it really is awesome because at the point that we did it, we were just changing volume definitions. We weren't changing the whole approach to storage or anything at that level, because it's just where does it map and what is the volume, and those are the only two things that we had to really change. So is easy to explore and sort of shows how that can be. Same thing for storage or other components that we may need to swap out.
Yeah. I think, well, somebody just asked a question about VRAM. About VRAM bursting while time slicing. Oh, we do that. We're very good at bursting and breaking GPUs. It's beautiful. Could you implement a kill feature? You know what's hysterical about this is we already have this for VRAM, or sorry, not VRAM, for RAM. Not VRAM, but so the interesting thing is Kubernetes natively does not like running interactive workloads like we're doing it. So there's a lot of like safeguards that are not that are put in place, but it's to protect the node. It's not to protect the workstation. So what we do is at Juno, we have a process that goes through and watches RAM usage on the node at a whole level. And if the RAM starts to spike on the node, we'll go through and we'll start enforcing limits to try to protect the node. Because if you don't, then the killer comes along and absolutely murders all the pods. So it'll kick all the workstations and you'll lose everything. Juno itself goes through and watches this and makes sure that if you start to saturate the RAM usage, we'll start flagging like, hey, you need to start clearing your cache or doing something. And if you don't do that fast enough, then what we'll do is we'll start limiting to protect the node. Now, VRAM's a little different because the API is different for hardware, each hardware. So it's a little bit more difficult to do that, but the API is there. So for example, in Kuiper, if you had something like a Kubernetes daemon set that's watching the node and it sees like VRAM starting to spike on this node, you could fire off an eviction off of the pod or like fire a warning saying, hey, you're starting to run out of VRAM, and you could evict those workstations off of there to protect the server if you really wanted to. But that's an example of where Juno doesn't have an opinion on that. We give you the tools to do it, the Lego blocks, but it's totally up to you how you want to do it. Maybe in the future, we'll provide a way that's just like, this is our recommended way of doing it. We've started doing that with, for example, Donald and his team. We do have recommended ways of doing it, but we don't enforce any of them. It's totally on them how they want to do it.
There's a question there about, well, actually several questions. It said, Donald, can you talk about how you're able to scale compute, thinking about running compute on hundreds of shots in an automated way?
It's from Robin, yeah.
Oh, yeah. Well, I mean, the cool thing about setting up the supporting infrastructure with Juno's canonical provided, very handy GitOps provisioning code for that infrastructure, once you're deploying your node sets that everything runs on, at least in our case for AWS, we already had a pretty confident definition of what was working very quickly. And we decided, hey, why don't we go ahead and, since we know our GPU is what we want to go with, at least in this particular node group, we already had a maximum allowed for our own safety of nodes that we really wanted to fire up. And we just did one git commit and took it to that maximum and started replicating the workflow that we already had. Although we had to like introduce some other governing features to queue that workload around and make it actually itself coherent and efficient. It's really down to one line of a commit that we were really changing to alter the way that we were working from development to pushing out the scaling of the production there. And yeah, Nuke, the cool thing with the definition that we're using from Juno already, the Polaris workstation definition, we as well didn't want to reinvent the wheel and decided to do the Nuke automation that we were automating in a headless way against that directly. So we were able to just start running Nuke as if it were an artist on a workstation and scale that out as if there were 90 artists trying to select workstations and do a whole bunch of work at once. So that's sort of the cool thing, is as things scale in and out, we're not really looking at automation and users in a different way with the system.
Yeah, and I mean, it's kind of cool too that Juno itself at AWS, because we do have a very good relationship with them, we have done load bursting as well to go through and like, I think we've scaled up to a few thousand EC2s before, and then we've sliced those EC2s 3 times. So, I mean, it's at least 3,000 containers all running at once. So you can operate at scale, but that's something that we've never really worried about because it's Kubernetes is the backbone of so many high volume applications that the scaling's never been a concern of ours. We've always been able to do that. Another benefit of why we lean on them so much. But that's kind of where, for us, Juno does have really, really good, healthy bones in it that can reach those crazy scales if you need to.
Yeah, we're almost at the top of the hour. There are a couple of questions about, someone asked about Adobe running, but they weren't sure that that ran on Linux. And on top of that, the million-dollar question is, what's the timeline for Windows support?
Yeah, that's a great question. So yeah, it looks like there's two questions. I want to answer the last one too. But so as far as Adobe, yeah, we need Windows. There are already on the roadmap. We're hoping in the next month to 2 months, hopefully Windows. Windows is the big blocker there because obviously Adobe, for one reason or another, we have opinions on this, but whatever. They don't support Linux. So I wish everybody would just support Linux. But yeah, that's something where it is coming. But the primary issue is we can launch Windows, we can do all that kind of stuff right now, but licensing is an issue and hardware being passed through is an issue. The biggest catch there, though, is there is going to be a downside to it, which is it is going to be an actual virtual machine, which is a preview of what's coming in the future. So in the future, there are plans to where you will be able to not just run containers on this platform, but you'll be able to also you'll be able to manage virtual machines on the same platform. So this is going to be a mixture of a hypervisor and a container runtime. So that is coming. But we're focusing on just containers for now. But they're all going to be Kubernetes. And the cool thing is your VMs will have the exact same life cycle and treatment as though they were containers. So you'll get all the same benefits, which is really cool. Yeah, and as far as the AWS stuff, yes. So the cool thing here, so you do not need to manage the life cycle of scaling. So this is something that's really funny. When Juno was created, the biggest thing was it was connected to my personal credit card. Right. And so I'm not going to sit there and be like, no, turn it on. No, turn it off. Right. We're not going to do that. But if you look at like specifically the financial sector, it's really interesting because, like I said, I come from visual effects, and the problem with visual effects is we have a tendency to be like tunnel visioned on like, this is a new problem. It's only our problem and we need to solve it. Right. But if you look at, for example, a bank, right, when you make a transaction or you like go through and they have huge amount of influxes of even trading traffic that's going towards like the NASDAQ or something like that, there's not like a bunch of people sitting there saying like writing scripts to scale this stuff up and down and do that kind of stuff. Like it has influxes of like on times and off times, right? And that's completely automated. And the cool thing there is that the number one benefit to Kubernetes is its scaling. So the cool thing about this is because like when Juno is going through and running these workstations, they're treated exactly like a way a bank would go through and scale up and down and keep those margins in check. So all of the scaling is 100% automated. But it's really great because, again, like Kubernetes, if you're on-prem, you don't need a scaler. You don't need it because the nodes are already in the cluster. So you're not going to scale up and down. But if you're on AWS or GCP or whatever, you can use something like the cluster autoscaler, which is just a plugin in Kubernetes. Or if you're on AWS, you can use Carpenter, which is another autoscaler. And that goes through and automates the entire scaling up and down. And the great thing is it's tunable. So like Juno has incredibly aggressive scaling. So if you saw those render nodes came in, those were being scaled up. And then the moment that render was done, they scaled instantly back down. So at that moment that we were doing that render, that was us spinning up like 5 more EC2s. They were only up for like the 30 seconds that render took because we didn't send a big one. And then they scaled down a minute later. So that's how aggressive. So if you look at your AWS cost compared to your demand, we're almost 1-to-1 to exactly what the demand and scale is. And it's really, really cool. And that's just because we look to other industries to kind of learn about how this stuff works. I think that answered the question. And then I think the JV one, really, yeah. I mean, it's kind of the idea. Historically at Juno, the whole idea was we were just going to build this just for ourselves, and then we were going to go to market and just have this super secret, kind of like crazy powerful thing that we had built that nobody would know how it was. And then somebody convinced us in the future saying, hey, people would probably like to use this and you could apply it to a bunch of other industries. And so that's where we were like, hey, I think that's probably what we're going to do, is we're going to just, make this something available to everybody.
Excellent.
Yeah.
Let's see. Well, I think there's one last question.
Okay. The virtual workstations, can they be installed with any Linux distribution or nope? So the really great thing is that we give you flavors of workstations. So if you want Ubuntu, you want Red Hat, you want, you want Rocky, you want Alma. I think at Donald, you guys are running Rocky. So we give you Rocky, we give you Ubuntu, we'll give you Debian. For fun, we have an Arch one that is incredibly unstable just for fun. Yeah, Rocky. At Juno, for example, we run base Debian and we run Ubuntu. And then I think at Donald's other practice, they're using, it sounds like a doctor, other venture. They're running Ubuntu, but also at Nexus, I think they're running Rocky. And we have other clients who are using Alma. So it's all over the place. So we provide all the different flavors. And typically, if you don't have one, we also, just for fun, we have an Oracle one if you want to use that. So.
Nice.
Well, thank you so much, everyone, for joining us today and for also taking time to listen. A special thanks to Alex, Donald, and Dave for sharing your wonderful expertise. We will be following up in your emails with a recording of today's session, and we can also answer any question in there. So if you have any inquiries, please reach out. But thank you very much for listening to such a fun webinar today.
Thanks, guys.
Thank you.
Thank you.
Bye.